We're going to continue chapter 12 with the last concept in this chapter, which is shape of the molecules. And we have a fancy word for that here in chemistry. We call it VSEPR, which is a fancy way of saying valence shell electron pair repulsion. And so what the heck does that even mean? That means that we are learning how to explain the shape and how to draw the shape of molecules in 3D. So this is our best guess of what molecules look like in nature. So this, for example, has four things coming off of it. It has a center atom. And we're going to learn using VSEPR theory, which just really looks at the valence electrons and how they push each other away, what the shape name is. Okay? Now, the good thing about this is there's not much memorization here. I'm going to give you a chart in this class to use to learn this concept, so you just have to be able to utilize it. Now, we're going to be able to indicate two things about a Lewis structure. We're going to be able to indicate its electron pair geometry name, which is basically the arrangement of the bonding and the non-bonding and how they are arranged around the center atom. Now, I want to remind you that we have been using the term lone pairs for non-bonding, but either one of those are the same. They're the same thing. Molecular shape is another thing that we're going to learn how to name, and this basically talks about how atoms are around the center atom, and we take into account electron repulsion, and so you will see the difference as we look through some examples here. So you are going to be very reliant on this chart, so let's just talk about what this chart really means. There are things connected to a center atom. And when I say things, I know this is kind of a fancy word here, but things could mean a bond or a lone pair. And of course, I'll demonstrate what that means. So it's how many things are attached. We're only looking at 2, 3, and 4. Bonded atoms are basically atoms bonded, two atoms bonded together. And a lone pair, we know, have the two little dots. And then this is the electron pair geometry name you're going to reference, and then this is the molecular shape name you're going to be using. Okay, so you're going to rely upon this chart a lot. I will teach you how to utilize it here in the next couple of steps. So here is what these words are kind of representing in space. So when we have something that is linear means that it is going to have two things connected to it. And you can see here the linear shape has a center atom and two connections. So trigonal planar is a center atom and three connections. We can go ahead and look up here. Trigonal planar has three connections. And we're going to actually see that three things could mean that they are all bonded, or they are two bonded in one lone pair, and that affects the molecular shape name, which you're going to see down here. And then our last one we're going to look at here is tetrahedral. It has a center atom and four connections, okay? And again, those four connections could be all bonded atoms, or three bonded in one lone pair, or two bonded in two lone pairs. No matter what, if it's four things, it's still called tetrahedral. It's the molecular shape name that changes when we are replaced with lone pairs. So to do this, I'm just going to demonstrate. To be able to indicate the electron pair geometry and the molecular shape name, you need to have the Lewis structures. So I'm using the Lewis structures that we just drew previously in this PowerPoint, and so I just copied them down here. You're welcome to go ahead and copy them yourselves, or go back or try them again on your own and then match them to mine just as some extra practice. Now I'm going to walk you through how to do the electron geometry name, electron pair geometry name, and the molecular shape name. I'm just going to go ahead and use these acronyms here for this, and we're going to do it for each one. So the way to do this is you ask yourself how many things are on the center atom. In this case, there are four things, and you want to ask yourself a second question: are they all bonds or are they lone pairs? So for CH4, there are four things attached, and they are all bonds. So we're going to be flipping back and forth here quite a bit. I do apologize. So when it is all four things and they're all bonds, we're going to be looking at four things and they're all bonds, no lone pairs. So therefore, what I'm going to be looking at is tetrahedral, tetrahedral. Now you're going to say to yourself, it's the same name. Why do I have to write it twice? And you do, okay? You just have to write it twice. That's how we do this, because you can have a different molecular shape name. So just trust me on this. So the electron geometry name is tetrahedral. Now, if you move into another level of chemistry, this will mean more to you because you'll actually learn how to draw these. I'm not having you do that. I'm just having you classify them. So this can get a lot deeper, and I'm truly just teaching you the surface level things. So let's do this again. We have a center atom and we have 4 connecting atoms to it. So this actually is the same thing as the CH4. It doesn't matter what the bond attached to it is, even though it's Cl or H, it's still going to be the electron pair geometry name of tetrahedral and the molecular shape name of tetrahedral as well. Okay, and again, because they're all bonds. Now, NBr3 is our first one that, although we have 4 connections, 1, 2, 3, and remember, this is a connection as well. So there are 4 things connected, all right? But 3 of them are bonds, and 1 of them is a lone pair, right? We see 1 lone pair, and we have 3 bonds here. So that is going to take us into a different molecular shape name. So I'm going to go ahead up here and look at our chart again. So we have 4 bonds, 4 connections, 3 of them are bonded, and 1 is a lone pair. So that changes us. Tetrahedral is still going to be the overarching name, but the more specific name is called trigonal pyramidal. So that's all we have to do. All you're going to have to do is utilize this chart. I'm going to go ahead and just write tetra to save myself some time because you guys know what I'm saying here. The molecular shape is trigonal pyramidal. All right, let's continue doing some more examples here. So we have to see how many things are attached. 1, 2, 3, 4. So still 4 things. Remember, a lone pair is still considered a thing. So 4 things attached, 2 bonds, 2 lone pairs. I'm going to go back up here. We're now looking at 4 things, 2 bonds, 2 lone pairs. That makes it tetrahedral bent. Okay, tetrahedral bent. Tetrahedral. You'd write tetrahedral. I'm just saving myself some time here. Bent. Okay, so hopefully you're getting used to seeing this center atom. A lot of these, tetrahedral is the most common, so that's usually what you're going to see. 1, 2, 3, 4 connections. Okay, that is, and since they're all bonds, it's going to be tetrahedral as the electron geometry name, electron pair geometry name, and then the molecular shape is also going to be tetrahedral. All right, so now is our first one where it's a little bit different. So when I count the amount of things, I know this is a little bit confusing, but you have to count the amount of things as how many things are connected to it. So carbon has 1 thing and a second thing. It doesn't matter that it's a double bond. A single, double, triple bond, or a lone pair is still considered just 1 thing. So when we look at this, we have 2 things connected to it and no lone pairs on the center atom. So we have 2 bonded atoms. No lone pairs, we call that linear and linear. Okay, linear and linear. So this is our first one, it's a little bit different. So our electron geometry is linear, and our molecular geometry name, or shape name, excuse me. They've changed the way that we word this so many times over the years that you could watch previous videos or find other people and they would call it molecular geometry or shape name. There's just so many names. I'm going to try to be consistent with these, but if you watch something else, you never know what you're going to find. All right, so then this now is another example here. We have sulfur. It has 1, 2, 3 things connected. Go ahead and reference your chart there, and they're all bonds. So our electron geometry name is actually going to be trigonal planar. And our molecular shape name is going to be also trigonal planar. Again, all I'm doing is referencing my chart. I'm going to look at HCN. It has 1, 2. A triple bond is still just considered 1 thing attached. So carbon has 1 thing on the left side, 1 thing on the right side. There's only 2 connections. That makes our electron geometry name linear. And that makes our molecular shape also linear. So you can see the difference between these two, okay? They're both linear, but one has 2 double bonds on each side, one has a single and a triple. It doesn't matter, it's still considered 2 things. And then this last one, we see 1, 2, 3 things, and they're all bonded atoms, so it's gonna be a electron geometry name of trigonal planar. And we're also going to use our molecular shape name as trigonoplanar. Now, I do want to tell you guys there's about 100 extra. We're only learning truly the main ones. There are so many others you may have to learn if you've taken other classes or going to take other chemistry courses. So I'm trying to make this as easy and as introductory as possible by giving you the chart. Okay? We'll do a little bit more practice of this in class. So our summary of this chapter is we learned chemical bonds. Make sure you understand the properties of ionic and covalent, and I shared a couple properties here. Make sure you know how to draw Lewis structures very comfortably because you have to be able to do VSEPR, and I will give you that chart on